Well, that was a really interesting presentation from Shepard because, in fact, it's mostly what I was about to say. But the use case is quite different, but the tools and the approach is quite the same. Laval University is in Quebec City, Canada. We're ranking number 6 in Canada for research. And that means that we have data scientists on the campus, actually the picture of the campus, but that makes a population of about 3,000 people who will qualify as data scientists, who are researcher, graduate students, and so on. And those are the people we are trying to help with a data science platform that very closely resemble to what has just been presented. So a few words about the project that we have. The data services, we call it Valeria. That's kind of a brand name. The idea is to provide professional services such as consulting, support, and consulting, support, and training around all those data science and machine learning things. And of course, we will base our services around the technological layer that we have with our own data centers on the campus, what we have at Compute Canada or Compute Quebec, which are resources that are freely available to all researchers all throughout Canada, and of course other services in the cloud that we can also leverage. So the idea is exactly as was presented, to have a central data lake with some storage capacity and compute capacity, on top of which we will have data valorization and management tools. So those are mostly for transferring the data, real-time ingestion, because in research we are using more and more sensors and data scraping from everywhere. And the resources that we currently have, whether at Compute Canada or on the campus, do not tackle this new style of data ingestion. So we have to provide this in our new platform. Of course, tools for processing, visualization, and analysis, and storage, and access and catalogs. But those are mostly technological solutions, and we want to abstract this layer of technology to our researchers so that they are able to use it in a much easier way. And that's where we will provide to the service access to data scientists / data engineers who will help our researchers to take the most of everything that we are putting up. Through the project, we are also working on the data management framework. We were talking earlier about access and security and things like that. That will be part of this management, and of course support and training. So, if I look at the architecture, we are quite lucky here on the campus, as we have 4 different data centers with, of course, optical fibers covering the campus with connections from up to 100 gigabits. But also we have our own network, fiber network, all throughout the city, that is to connect our research centers that we have in different hospitals and things like that. So we have a very efficient network, which will allow us to have this concept of a completely central data lake and the computing resources that will be accessible by all the research community of Laval. We made some technological choices for this project. So first was to redesign totally the network with 100 gig links all throughout the data centers and 40 gigs where it's not necessary. We also use Ceph for object storage, especially as we can leverage those 4 data centers to have all our data spread across different physical sites. Those are completely isolated sites geographically, but in fact it's the same leaf and spine network that will spread throughout the data centers. Usually we come from the world of HPCs, so it's mostly based on Lustre for the file system and things like that. But here it's a complete change of architecture. We go with Ceph, which will be much easier for us to interact with the data and move it around. Of course, it poses other challenges, which I will talk about a little bit later. Also, we will use OpenShift, otherwise I won't be there. For, we have some experience with it in our institutional applications. We've been using it for almost 2 years now, and we want to leverage this experience for this new data science platform because it's much more efficient and agile and versatile in what we want to do. And last choice was no Hadoop. Usually in data science, the standard installation and what we see throughout different research labs was based on Hadoop. And here we took a radically different path, as we are not setting up an infrastructure for a specific lab or specific department. It will be a completely shared service. So that means that we don't know yet at which path which part will grow, whether it is storage, whether it is the compute. So from the start, we have to separate everything. And once this has been done, and we chose to use Ceph storage, well, in fact, there's no need of Hadoop, as we can directly use Spark and TensorFlow and all those new things directly without the use of the standard Hadoop. We will also provide some end-user tools. So here it's Apache NiFi for real-time ingestion, which will be a little bit easier to use for researchers than directly programming Kafka and things like that. We will offer Pentao for ETL, and of course, Jupyter notebooks. If we look at the technological landscape, we have our data scientists on the top left, which will still be using their standard data analysis tools, JUMP and or RStudio, SPSS, something like that. But we want to offer those applications, tools, and services which are on the top right for data ingestion, data discovery, which is very important for us. It's not just about having data in a central data lake, but it's about finding it. And right now, we lack those kind of tools, such as Dataverse or CCAN catalogs or iRoads for the data management and things like that. We want to, of course, have Jupyter and R notebooks on demand, and we'll still offer those HPC services, which are much more natural. On the bottom part, you can see the different applications and tools that we will use. And in fact, we don't pretend in this project to invent anything. Those are standard applications that you can find. Here, our project is much more about integrating all of this in a seamless experience for our users. And here, if it works, I can make a small demo on the kind of experience that we want to offer. So here it's look at the portal, and please, it's only a small proof of concept that we did. Here, let's say I'm a researcher and I want to use the Valeria platform. Then I am redirected to a Keycloak instance. We have integrated Keycloak in the project, so I can register. I can have a new login. And here, for easier signing, it's coupled. Okay. So here, once I'm logged in through Keycloak, I have directly access to the portal where I can find Jupyter, GitLab for storing the data. Soon we will have CCAN and of course other services, more standard services like databases and access my storage and everything. So here I'm a researcher. I am able to launch Jupyter Hub. I have a selection of different types of notebooks that I can choose. Here, for example, let's say I want to do some SciPy, and then I click on Spawn. Everything is based on Kubernetes, on OpenShift. So here, as I launch my notebook, here you can see a new pod, which has been instantiated. It's under my name directly because as we have the integrated authentication, I can gather all the data that are necessary. You know, of course, username, but maybe some other restrictions and things like that. And I cannot show you it to you right now, but we have a new version of this where I would be able, depending on my credentials, to select how many CPUs I can run, which memory, if I am able to use GPUs and things like that. And here I have my Jupyter notebook, which is right now it's backed by an S3 storage. You know, as we are running inside OpenShift, we had to decouple the storage, and we didn't want to use persistent volumes in OpenShift or this kind of thing. It's better to have everything on the self storage, which is much easier later to interact with other applications and other tools. So here you have everything, and those are, well, standard notebooks, so it's not really interesting at this point. If I go back to the presentation, give you a small status on the project. We have worked with Red Hat to validate that Ceph could be indeed used as a data lake solution for running heavy Spark workloads. In research, we are talking about petabytes of data and very, very heavy compute. We have some genomics computing that takes a few weeks to run. So we wanted to make sure that we would have a sufficient performance with Ceph or Spark backend. The results are currently being published by Red Hat. It's something that we are doing in common. Short answer is yes, it works. Of course, there is some drawback in terms of performance, but still, regarding the versatility that we have by using an object storage and regarding cost efficiency, it's much better to run right now with Ceph directly than with standard Hadoop. As I said, the network has been redesigned. As I just showed you, we have this working proof of concept with Jupyter on OpenShift, with the self-provisioning of the different flavors of notebooks and things like that. We have also OpenShift working with the Red Analytics with Oshinko for Spark. We have another one I didn't mention with Dask for scheduling other compute process. We have Apache NiFi. We have the complete single sign-on across all the solutions, which really makes things very much easier for everything that you want to do. And what's next? We are working on the CCAN integration with Jupyter, so that is the ability directly from Jupyter to interact with CCAN to preload all your datasets, the datasets that you have bookmarked or your favorite datasets. They will be directly imported in Jupyter on launch. We are working also to have some other CCAN extensions to be able to, let's say, for example, I have a data set that I find interesting and I want to do some pre-analysis on this. So here it will be very easy with only one button to spawn directly a notebook, have it connected to the right data set, import the data set, and then I am able directly to interact with it without doing almost anything. We still have to work on the Globus integration. Globus is the kind of the standard way to exchange data in between different data centers. For example, we have in Compute Canada, we have those big facilities in the west, for example, in Vancouver or in Edmonton. So whenever we want to leverage those HPC power, we have to move the data from point to point. So we do it with Globus at very high speed. We want to use Vault as an integration to store all the client secrets, because we As we use an S3 storage, usually if those are not public resources, you have to integrate at some point the secrets to connect to the storage. And those are the things that usually you pass through environment variables inside the notebooks. So whether you do it directly in the notebook itself, which we don't want to do, because at some point, if we want to version those notebooks, of course, we don't want the secrets to get into the databases. So we have to directly have those environment variables set at runtime when the researchers are launching Jupyter. But we don't want them to manipulate those secrets and things like that. So we are trying to find a way to use Vault once our researcher is authenticated to directly manage the secrets for them and inject the secret at runtime inside the notebook when it's done. And of course, we're working on many more things. We are working also on Kubeflow. We are developing custom kube spawner to use inside OpenShift to be able, as I said, to gather different information and launch notebooks with different parameters, and lots of different things that I don't remember right now, but that's about it. And of course, everything that we do, all those new technologies and integration and things like that will be published open source for everyone. It's very important, especially as a university, to have other universities embark on this journey. And that's it.
This is amazing stuff. I promise you, this is not the how do you do more Kubeflow meeting. But I will say that last point that you had on what's next, particularly relative to spawning and integrating compute resources into Jupyter, that is probably the most requested feature that we've had in Kubeflow. I would love to get your thoughts on it.
Yeah, didn't catch the end, but yes, sure. Those are definitely parts that we want to test and push to the limits. And this integration is very important because our researchers, they are not IT people. They are not even data scientists yet. So here, the mandate that I have from the high management of the university is clearly stated as, Guillaume, we want our researchers to do research, not lose time in setting up infrastructures, setting up libraries, and find the right way to work. No, that's a total loss of time for us. So we want to have it as seamless as possible.
Yeah, I couldn't agree more. If you have a chance, it wasn't OpenShift related, but as you know, as everyone knows, OpenShift is Kubernetes, so that the two are should be totally compatible. At Next last week, I demonstrated using the cluster API and auto provisioning of nodes, being able to just describe a number of CPUs, number of GPUs, and your container image, and creating an entire node pool for your Kubernetes cluster for a job to run in. It spins it up, it creates it, it runs it, it stores the data, and then it shuts down. And the bridge between that and doing that from Jupyter Hub should be very, very small. So I'd love to get your thinking and how we can help data scientists execute that very step.
Hey, David, was that session recorded by any chance? And
it was. Yeah, absolutely. I will find it and put it in the chat right now.
Awesome. That would be great.
I'll even deep link in.
Cool.
Something I did not mention that comes to my mind, maybe it would be some interest for you. As we come from HPC, from the HPC world, we have managed to integrate CVMFS inside our notebook images. So like this, we have access to directly precompiled modules for calculation and things like that without having to have them inside the image. So that means we keep the images as small as possible with access to a huge amount of different scientific libraries without having anything to do. So this is something also that we want to share in terms of recipes and how to set it up.
Perfect. That's Guillaume, very much appreciated you sharing this use case and helping us understand what you're doing there, and incredibly impressed at the work that's going on. I think we all are. If you could add your slide deck link to the notes, that would be great. Same with you, Sherard. And